What's poppin', dogs? Mr. Allen here with some solving of logarithmic equations in this video. And for these two, we're going to need to use some properties of log. So bust those out, all right? We got log base 5 of x plus log base 5 of x plus 24 equals 2. We got to solve it, check for extraneous solutions because there are domain restrictions when it comes to logs. No zero, no negative in the argument. Cool? Dope. Awesome. All right. What do I do here? Well, I got two different logs here, same base, right? So that means that I can condense them into one single log. Addition condenses to multiplication, so let's rewrite that. I got log base 5 of x times x plus 24 equals 2. All right, I got one log here. Want to go ahead and distribute on the inside. And I think if you'd like, you could always jump down to the step that I'm at right now. That'd be totally fine. You can do that multiplication, that distribution, on the fly there. I like to show all the steps in these videos just in case you're like, how'd you get here? I got here, and then I got here. Distributed that x into the x plus 24. All right. Now I'm at like a dead end, right? So if I'm at a dead end and I'm in log form, it would be advantageous perhaps to loop and swoop this bad boy and rewrite it into exponential form. I like to call loop and swoop. I learned from Mr. Thornley. Shout out Thorn Dog. So we got 5 to the second power equals my argument right there, x squared plus 24x. You might be wondering, why am I calling it the argument, right? Am I trying to start something? No, I'm not trying to start an argument. This is called my base. This is called my argument of the log. My answer to the log is the exponent, hence it being in the exponent here in exponential form. Cool? All right, dope. 5 squared is 25. What's funnier than 24? 25. SpongeBob reference, in case you did not know. All right, I got a quadratic. What do we do here? Oftentimes we panic. We're like, oh my God, I've never seen something like this. Yes, you have, since freshman year probably, or 8th grade, or whenever you took Algebra 1, right? It's quadratic. We got to set that bad boy equal to 0, factor, my favorite F word, and solve. So we got 0 equals x squared plus 24x minus 25. What multiplies to negative 25 and adds to 24? What? How about 25 and 1? Oh, x plus 25. That one's going to need to be negative. That way I can multiply to negative 25 and I add to positive 24. So let's set these two factors equal to 0 and solve. Actually, I'm going to run out of room here. So we'll say x equals negative 25 and x equals positive 1. All right. So do they both work? Not so fast. When I plug into the original, the red one up here, I'd get a negative 25 in my argument. There's no 5 to some power that will give me negative 25. But not negative 2. 5 to the negative second, it's 1 over 25. So this cannot happen. But 1 going in there, I get log base 5 of 1, log base 5 of 25. That works. Log base 5 of 1 is 0. Log base 5 of 25 is 2. 0 plus 2 is 2. Checks out. Cool? You dig? Because I dig. All right. Now here's the thing. If this were our original right here, then both of these answers would be acceptable. Because if I plug negative 25 in here, it's positive 625 minus 600, which is 25, and I get log base 5 of 25, which equals 2. So in this form, I don't have the extraneous. The squaring takes care of that basically. But in the original here, which is what matters for this problem, this guy doesn't work. That guy does. Cool? Awesome. On over to the one over here on the right. Let's see here. What color? I'll use orange on this one. Okay. Some log base 2s. You might be tempted to be like, hey, we got all log base 2s. Can I just be like, gone? 1-to-1 property? Not so fast. Because it's not 1-to-1. I got 2 over here and 1 over here. How about we condense the left side? Let's do it. So I'm going to have log base 2. And it's going to be 3x times x minus 1. This one I'll do on the fly. I'm going to have 3x squared minus 3x, right? This would get distributed to these parts, okay? This is unofficial math notation here. That's like street math right there, okay? Where it's not official, right? I should put it in this form, show the distribution. We're skipping steps here. Because I'm crazy like that, dude. Okay? Keep track of your stuff. That's how I got that, right? Cool. Enough about that. Anywho, now I got log base 2, which means that my arguments would have to be equal, right? If it's the same log base and they're equal, the arguments should also be equal to make this true. So let's set it up. We got 3x squared minus 3x equals x plus 4. My goodness, we have ourselves another wonderful quadratic that I need to set equal to 0 and solve using factoring, my favorite F word, second favorite F word, fraction, third favorite F word, if you were curious, function. Okay, moving on. I got a lead coefficient, man. It's unfortunate, right? Now, you could go to the route of rainbow method, right? These two multiply, figure out what multiplies negative 12, adds negative 4, do this whole algebraic thing. Or you can guess and check, okay? Right? Check this out. This is how the tough people do it, okay? T-U-F-F. Tough. I know to get 3x squared, it's got to be 3x, and it's got to be x, okay? It's the only way I can get 3x squared. There's no other way. Or x and 3x, but whatever. Now I got to multiply to 4, negative 4. So they got to be positive and negative. That's tough. And then it's got to add the negative 4 when multiplied out. So a bit to think of here, but doable because there's only two ways to get negative 4, right? It's 1 and 4, 2 and 2, one of which needs to be negative, so like kind of a little more than like 2 ways of doing it. But I usually start with the two that are closest together, like 2 and 2. So let's throw them in there, 2 and 2. And now we need to, so that's our guess, and we also need to guess where the positive and negative goes, okay? So let's think about this. If I put a positive, or so let's start this way. If I put a negative here and a positive here, okay? If I put negative here and I put positive here, I'm not gonna, well, I'll write it, okay. I would get 6x when I FOIL it out, negative 2 when I FOIL it out. 6, negative 2, unfortunate, yes? That's positive 4. But hold up. What if I switch this and, we're erased pretty good, and switch that? Now I have negative 6 and I have positive 2, which adds up to negative 4. You can also check early, like, oh, it's 6x, 2x. Which one needs to be negative? The 6. I'll put the negative here so that it becomes negative 6x. So we guessed, we checked. Awesome. It's tougher at first, but if you get better at it, you're going to be okay. And most of what you see in factoring later on after our big factoring quadratics type units are pretty manageable numbers. Small, 3, 2, 5. Prime numbers, right? We give you some easy ones to work with, and you'll be able to work a little quicker through with guess and check. All right? So we're in factored form. Now I can set these equal to 0. 3x plus 2 equals 0. X minus 2 equals 0. I'm going to get x equals negative 2 over 3. And I'll get x equals positive 2. So before we circle our answers, are either of these extraneous? Well, if I plug negative 3 over 2 here, that's going to be negative 2. No bueno. That's out. That's extraneous. If I plug a 2 in here, I get 6. I get 1. We're good to go. Both are positive. Oh, and 2 over here is 6. Cool. So I do have to check all 3 of them. It has to work in all 3. But if it doesn't work in a single one, does not matter. This over here works in this one, right? It works there. But it doesn't work in either of these two. So it doesn't work, okay? If it doesn't work in one of them, does not work. It's extraneous. If it works in all 3, we're good to go, all right? This leads itself to a nice little multiple choice question of saying, which of the following is an extraneous solution? That would be my answer. That would be my answer. But if we just want to solve it, those are my 2 answers. That's about it. That's dope. Hope you guys have a wonderful day. If you need help with some factoring, be sure to hop on over to some of the factoring review videos that I have because factoring never goes away. See ya.